All right, take it away, Bill Burdick.
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 Welcome to Retro6502. So, how can Julia help with 6502 development? I mean, setting aside the idea of compiling to a 64K machine. But first, let me see if I can start up a terminal here. Sorry for the dishevelment here. Okay. I need to. There we go. Oh no. Hold on. Shoot. There we go. I didn't go through my ritual. Gives me a little time to first X here. This is when I was going to play the music to a Commodore 64 game called Comic Bakery, but I don't have time to do that right now. But it's by Press Play on Tape, covering Martin Galway's song. I'll put links in the YouTube if I can. Let's see. Okay, so I just loaded move.jas. That's the Julia assembly language. I'm going to assemble it, which also has some time to first X. Okay. Oh, I haven't synchronized my changes. Darn it. Oh well, this isn't as nice as it could be because my laptop has the more recent code. But so you can see we've got this Commodore 64 screen running interactively. That's kind of a useless monitor there because you can't really track that with your eyes, but I'll get breakpoints in there at some point. And then we can see, let's see, the characters on the screen. Over here you see the ASCII. Well, that's the screen code, the Commodore 64 screen code character. And if I hit Control Q, I'm back in the Julia REPL because this is actually all inside of a terminal. Because, you know, there are lately have been some developments to display and interact with real bitmap images inside of terminals. So I thought it would be nice to just extend the Julia REPL this way. So I have to find my slides. Oh, I'm on a different, okay. There we go. That was the blinking lights. Okay, so we've got this ASM REPL. It extends a Julia REPL. It's screen-oriented like the Commodore 64, and it kind of looks like the Commodore 64. Supports different layouts. It uses a worker for assembly because I've got this pure Julia 6502 emulator, and I'm using eval a lot, and it scribbles into the Julia environment, and so you want to be able to throw that away. And right now there's not a good way to like reclaim resources for like identifiers that you've defined inside of Julia. So I use workers for that, so I can just kill the worker and restart a new one if I want to clean up the environment. And so I've got basic style load, save, run. So you can load, but it's for assembly code, but you can load an assembly program, make some changes, you can save it out, and it'll watch the file too, so you can just edit in, Emacs or VI or whatever. The assembler is there. One of the standard assemblers for 6502 is the TAS64. So this kind of, my assembler kind of conforms to a lot of its conventions, just kind of standard assembly stuff, but you'll see it uses 0x instead of $, because all the expressions in the assembly file are Julia. So like the TAS64 has a bunch of directives, and mine didn't need so many because Julia provides everything else. You don't need an if directive if you can just stick Julia in there. These are the standard functions that come with TAS64. I defined a few others, but I also get every function defined in Julia if I want it. So here's an example data table. And my friend does Commodore 64 development a lot. He came out with a game he published in over COVID for the Commodore 64. I have it at home on a floppy. And so you can, so what this does is it defines a data table, and the Commodore 64 has 3 registers. They're 8 bits each. So managing data is hard in C64. So like if you want a table of addresses, you make 2 parallel arrays for the low bytes and the high bytes of the addresses, and then you index that with X, and then you load each, the high and low, into different registers. So that's what this does. And he was like, that's a error-prone process. How does your system handle that? So I did it in 2 lines with Julia, and then I added another line to align the code on the page boundaries, which was more logic. And then in my other changes, which I haven't synchronized, I just made it conditionally and aligned only if the data would cross the page boundary. So here we can see, here's the Julia code. It's just normal Julia code, and I'm just using eval a lot, and I'm using the parser to find the ends of the expressions. And then to use it, something you don't normally see in an assembly file is like multi-line parenthesized expressions like this. So you just, we've got Maluba and Fred data items, and I have the addresses right there in just a regular Julia array. And I pass that as an argument to the adder table macro. This is the movement program that I was just running on, that you saw on the screen and thing back and forth, right? So the bold code there is in Julia. So I've got some fake routines there. So in order to do this, because I don't have a super high fidelity hardware emulator right now, so I can't do sound, and I can't do the I/O on chip, like in the emulator. So I patch in fake routines there with the .fake directive, and that hooks up to a Julia function. So that way you can call in and out between Julia and the emulator. So you can prototype your 6502 code in Julia, and then like after it works and you've tested it, you can translate it into assembly, and then you can you can drive automated testing from Julia and verify the 6502 routines against your Julia functions if you want to, because you have full control over the emulator. And the way it does the fake is it starts them at 0 and it just gives them consecutive addresses, even though that consecutive addresses don't make sense in a 16-bit addressing system with 8-bit words. So you know, you've got them like overlapping, but it's all fake. And so I just patched in scan key and get in to call the Julia routines there. And those are the real ROM addresses for 6502 routines there, but I'd have the ROM swapped out. So it does do the bank swapping, so I can like actually use C64 ROM, but since I don't have a high fidelity emulator, I can't actually run the ROM code to scan the input because I'm not emulating the keyboard scan lines and stuff. Yeah, that's just the highlighted Julia code. That's pretty much what I have. Future directions, I do have a rewinder, so I can do like omniscient debugging, but I don't have like full hooks into that. But I do have like in another with some disabled code, I have a slider where I can go back and forth in time and see hello world unwind, you know. So, and what I'd like to do eventually is have, you know, you can just create emulators. They're very low, lightweight on, you know, a machine this powerful, because, you know, it's 1 megahertz machine that we're emulating. So, what I'd like to do is do like probable futures, and so like a series of screens that go off into the future, and as you're like playing a game and you're debugging it, you can see what happens if someone were to, you know, make the joystick go down instead of up. So you can see, you know, it's kind of a little sci-fi, but I think it might be useful to be able to like view into the future. Also, I like to make a test, like a full test harness for doing, you know, testing, because currently people when they develop on 6502, they write their test code in that it runs inside the emulator, and they have to write it in assembly code. So that's it, I think. Oh, it's related work. There's some interesting, the Turbo Rascal syntax error project is interesting. It's a kind of a low-level Pascal. It generates 6502. The kick assembler is written in Java. Includes a high-ish level scripting language, and you can extend it with Java, but you have to like run it in Eclipse and write extensions and link them in and stuff. And then 64TAS is the other kind of standard one. Shoot, and my QR codes are on my laptop, which wouldn't work. So.
Thank you.
Yeah. So that's my talk. Are there any questions or?
Very briefly, do 1 or 2 questions. Where's the microphone? Perfect. Some questions still? Yeah, over here. Cool.
How did you get into all this Commodore 64?
Oh, yeah, I was supposed to talk about that at the beginning. I started working on a game for Commodore 64, and I was like, this is so tedious. I need if I had Julia, you know. So I'm like, what? And then I was thinking, what could I have done in the 80s if I had Julia resources available to work on the Commodore 64? So.
Is there still a market for Commodore 64 games?
Well, it depends on what you mean by market. There are people who are interested. Yeah, like my friend published a Commodore 64 game in 2021. So
Okay, cool.
yeah, there are people out there, but you won't get rich unless you find a very rich person who wants to commission a project like like a patron of the arts, you know.
Further question?
So I noticed that you didn't have all the directives. Does this run arbitrary Commodore 64 assembly?
No, I have my own assembly, so my own assembly language. So I didn't need all those directives because all that stuff's already in Julia. But so it wouldn't run a normal, like if I took assembly source code for like the TAS64, that wouldn't work because it's capable of doing everything and more that TAS64 can do, but the syntax is so wildly different, it just wouldn't work.
Okay, and then can you compile things? Like, can you run the assembly that you're creating on Commodore 64, or is it just like two separate?
No, you can if you're not like patching into fake Julia routines. If you're patching into fake Julia routines, then it has to run inside the Julia environment. So the model that I'm going for is like prototyping in Julia most of the stuff, and then gradually translating that into assembly, and then once that's done, being able to test that against, like keeping the Julia code around for test purposes so that you can verify the results. But then you'll have a binary, a portable Commodore 64 binary that'll run on my, on my Steam Deck in an emulator or whatever.
Thanks.
All right. One more question. Otherwise, okay, see one more last question, and then we can all go for a break.
So you got things running in the REPL. So have you managed to play Bad Apple in the Julia REPL yet?
I don't have enough support. I can't even do sprites right now. So my first goal is to be able to do VIC-20 games, which is a pretty low bar, but I'm not there yet. It's over my head at this point. But it does do real character graphics from the ROM. So.
Okay, thank you. You want to have one more question? Okay, very quick one.
Can you tell us a little bit more about bitmap support in the terminal? You mentioned
Bitmap
it
in the
earlier.
terminal?
Yeah. So how
Yeah.
does that work, and how are you using it?
Okay, so I'm using an old standard called Sixel, which is from the late 70s, created by DEC for printers. And it has 6 pixel columns at a time that it can print. And this is a standard graphics capability that's been around for a while, and I think Xterm supports it even. Kitty does. Kitty's pretty advanced. That's what I was using. And KDE Console supports it. But there was somebody in 21 during COVID who didn't think that was enough and came up with an entirely new graphics protocol that also supports mouse input pixel by pixel. Right now you can do mouse input, I can currently support mouse input on just a character by character basis. So I can click the mouse on the screen to send input to it, and click the mouse on the REPL to send input to the REPL. But what I'd like to do is take advantage of the new standard so that you could hover over a pixel and you could get information about the pixel that you're on. And once I have the omniscient debugging fully patched in, you'll be able to click on a pixel and get a program history of how that pixel, the lifetime of that pixel, and what changed it. What if you click on it, go to the code that set that pixel at that point in time. So.
I would like that. That sounds pretty cool. Okay, thank you.
Thanks.